A scientist has 50 grams of a chemical. The scientists need to fill small bottles, each with 1.6 grams of the chemical. We're going to answer these questions. How many bottles can the scientists fill? What is the total mass of the chemical that was used to fill the bottles? How much chemical will be left over? And can the leftover amount be divided equally and added to the bottles? First question, how many bottles can the scientists fill? The total is 50 grams of the chemical, and they want us, or the scientists need to fill each of these bottles with 1.6 grams, 1.6 grams per bottle per small bottle. And so we need to see how many times can 1.6 fit into 50 grams. That way we know how many bottles the scientists can fill. So our dividend will be our total. So 50 divided by our divisor, 1.6 equals. And we're going to turn this into long division. And we're messing with a decimal. Cool. So the divisor stays outside the long division symbol. Oh, that's not a good long division symbol. There we go. And the 50 goes inside the long division symbol. And so we need to carry this decimal to the right. And whatever happens out there, same thing happens here. And so now we have, I erase all this. We have 16 outside and 500 inside. Now let's write this up here for space. So 16 and 500. So this is over here now for the space. And I go ahead and erase all this. And let's begin solving this problem. Now, how many times can 16 fit into 5? You can't. So that'll be 0. And then you multiply 0 times 16 is 0. And then 5 minus 0 is 5. And then we bring down the 0, and now we have 50. Now, how many times can 16 fit into 50? Well, if I guess 16 times 3, that is 48. So it can't be 16 times 4, because that will give us 64. So we write the 3 above the symbol, long division symbol, and then we multiply 3 times 16, and that gives us 48. And 50 minus 48, that gives us 2. And then you bring down this 0 down, and now we have 20. Now, how many times can 16 fit into 20? 1 time. So I'll write the 1 up here. 1 times 16, that is 16. And 20 minus 16, that gives me 4. And now, can 16 fit into 4? No. So now we have to add a decimal here. and the decimal here and write a 0. And now we can use that 0, bring it down, and now we have 40. So how many times can 16 fit into 40? Well, we'll have to use multiplication. 16 times 2, that's 32. And 16 times 3 is 48, so we can't use 3, so it has to be 2. And I'll just write 16 times 5, because we have 2, 3, 4, and 5. And 16 times 5 is 80, just to keep it there. We may need it. And then we write that 2 up here, 2. And so 2 times 16 is 32. And 40 minus 32, that's 8. And 16 can't fit into 8, so we bring down another 0. There. And so looking at these multiplications, 16 times 5 is 80. So we can just write 5 up here. 5 times 16 is 80. And that cancels out. So the scientists can fill 31 bottles. And this is the remainder. Oops, I wrote a 1. It needs to be a 2 and 5. There we go. So the scientists can fill 1.25 bottles, or in other words, 31 bottles. Cool. Now, next problem. What is the total mass of the chemical that was used to fill the bottles? So the first thing you need to think of is, okay, we have 31 bottles. I'll write that in there. 31 bottles. And each of these bottles has 1.6 grams per bottle. So we need to add up the 1.6 31 times. So I'm going to go ahead and use this side. So this is multiplication. We have 31.0 times 1.6. And let's go ahead and solve. So 0 times 6 is 0. 6 times 1 is 6. 6 times 3 is 18. And then we write a 0 down here, and then we start with this side. 1 times 0 is 0. 1 times 1 is 1. 1 times 3 is 3. And so we add these up. 0, 6, 9, and 4. And there are 2 numbers next to a decimal point. So we move this decimal here twice. 1 to the left. 1 and 2 twice. So the answer is 49.6 grams. So 49.6 grams was used from the 50 grams. Now, how much chemical will be left over or was left over? So going back, we started with 50 grams and used was 49.6 grams. and we just need to subtract. So make it a little bit clearer here. 50.0 minus 49.6, we subtract. So 0 minus 6, we need to borrow from the 0 next to it. We can't borrow from the 0 next to it because it's also a 0. So we need to borrow from the 5. So this becomes 4, this becomes 10, and then 9 because this becomes 10. 10 minus 6 is 4. 9 minus 9 is 0. And 4 minus 4 is 0. And so the answer is 0.4 grams was the leftover. Cool. Now, can we add the leftover, which is the 0.4 grams, into each of the 31 bottles equally? I don't know. I mean, it's not practical for, I'll say, two main reasons. The first reason is because precision, it's not precise. Just adding such a small amount to each bottle might not be precise enough, and it will be difficult to do. And the second main reason, just cross-contamination. Contamination is spelled like this, C-O-N-T-A-mination. So if the chemical is very sensitive, adding it back to these bottles could increase the risk of contamination. So mathematically, we can distribute the leftovers mathematically, we can distribute the leftovers chemically. I say chemically, equally. However, it's not practical. So it would be a bad idea if we do. So there you go. We just solved this problem, or these 4 problems. Thank you for watching. Please subscribe to the channel. And again, thank you for watching.